there she is. Curiosity's twin, and she's big. I mean, she's the size of a small car, and there is so much kit. It's really hard to imagine how something like that gets sent out into space and lands safely on the surface of Mars and then roves around it just like that.
The job for the Earth-bound twin is to practice moving in this replica of the Martian landscape. It may not look much, but these variations of sand and stone are the best guess at what Curiosity might encounter.
It's so exciting to see it in action, it really is.
Yeah, it's a really cool robot, right? You're standing right up close to this thing that's taller than you are. Even though it's moving very slowly, it's kind of scary. Remember, it has a laser it could, shoot you with, so...
That's not even funny.
So, yeah, we're going to stay back here where it can't shoot us.
Scott Maxwell drives the real Curiosity. His job is to avoid steering a multi-billion-dollar vehicle into a Martian ditch. So the meticulously planned rehearsals with this twin are crucial. Right now, it's trying to navigate what it thinks are the sloping sides of a Martian valley. With the rotating camera, it takes 3 stills, which help it plot the safest route and avoid toppling over. Then it powers forward a few centimeters and begins the process again.
I love the way the wheels move. So this is going this way.
Yep.
So clever.
The record of the painstaking rehearsal is then sent up to the twin on Mars.
How fast can the rover go?
It goes, I think it's something like 0.1 of a mile per hour. 2.5 meters per minute is the number that's in my head. The reason for that is the rover masses about a ton, and it only has enough energy to run 2 ordinary kitchen light bulbs. So you think about trying to drive something around that's about the mass of a ton with enough power to run 2 ordinary light bulbs. And as you can imagine, it doesn't go very fast.
And why so little energy?
We've got a chunk of radioactive plutonium, and we've got a device that turns the heat that's given off by that radioactive rock into electricity, and that's about 110 watts. It's part of a complex trade-off to get basically as much power as we could in the rover without being too heavy.
Fair enough.
Meanwhile, about 140 million miles away on Mars, communication isn't good enough for video. So NASA has created simulations to help visualize the rover's journey. As the Martian dawn breaks, Curiosity awaits instructions.
We email the rover a package of stuff that says, here's your to-do list for the day. And then we go home and go to sleep. The rover spends its entire day carrying out those commands. And at the end of the day, it emails us back a package saying, OK, here's what I did. And on a good day, those 2 packages look the same. The things you wanted the rover to do look like what the rover actually did.
But on a bad day?
On a bad day, they're different. So far, we have never, harmed the rover. We've never driven the rover over a cliff or anything like that.
She's packed full of science instruments. Curiosity can look at rocks up to 12 meters away and zap them with a laser and look at the vapor, the spectrum, the light spectra of the vapor, and determine properties and mineral content of the rocks to understand whether she wants to drive over there and start to investigate more completely. We've got an ability to drill into rocky material and take out powdered samples, sort them by grain size, and then distribute them to science instruments in the body of the rover.
So have you had a moment yet where you've gone, oh, we should have put this on it as well? Or are you so far so good?
So far so good. Curiosity is our next big step, blowing out of the water anything we've done on Mars today.